In previous videos, we've talked about factoring a greatest common factor out of multiple terms. We've even talked about factoring by grouping. We're going to look at another type of factoring here. And in order to kind of understand where this is coming from, let's go back to when we learned how to multiply binomials together. So if I asked you to multiply x plus 3 times x plus 4, then we, of course, do that multiplication thinking about the acronym of FOIL. So first, outside, inside, last, right? Gives us those four terms. And then, of course, the outside plus the inside are going to be like terms in this case. And so we combine them into 7x. So x squared plus 7x plus 12 is equal to x plus 3 times x plus 4. But if you look at what we started with, that is a factored expression, right? It's expressions multiplied together. And so when you see something like this, then it might be possible to go from here and work backwards to a factored form of that expression. So I kind of unofficially think of this as reverse foiling. Um, so what we're going to do is we're going to start with x squared plus 5x plus 6. And we're going to think of these in terms of these terms that we see in terms of FOIL. So I know that if it did come from something that kind of looked like this, the x squared is the first times the first. The constant term, 6, is the last times the last. And then the 5x, the middle term, is the outside plus the inside. So with that knowledge, I can then think about what this thing would have to look like. So I'm not sure if I can write it like this, but if I can, the way it would have to work is I would have to have x here and x here, because first times first would have to give me this x squared. And then the last of 6 is going to have to come from multiplying whatever number's here with whatever number's there. So the problem is, I guess not a problem, but the thing that we have to think carefully about is the fact that there are multiple ways to multiply two numbers to make 6. So we can do 1 times 6, or we can do 2 times 3, either one. And so 1 times 6, 2 times 3, which one's the right choice? Well, understand that whatever number goes in these blank places, it also has to be true that the outside plus the inside, I'm just going to go ahead and kind of make this diagram here, have to add together in order to make the middle term. So if we look at these, which one would do that? If I put a 1 here and a 6 here, then I would get 1x plus 6x would give me 7x, which is not my middle term. However, if I put a plus 2 here and a plus 3 here, the inside is 2x, the outside is 3x, and they do in fact equal 5x when you add them together. So that means that the proper factorization of x squared plus 5x plus 6 is x plus 2 times x plus 3. So as a general rule, I can look at the constant term, think about the ways that it can multiply, and then you look at those different ways that it can multiply, that you can multiply numbers to make the constant term, and figure out which ones of those, if you put them in those slots, would make the outside plus the inside equal the correct middle term. Okay. So let's do another one here. So again, the process is if this factors. going to look like this. The only way to break down the first is x and x. X times x is x squared. There are multiple ways to make 20. 1 and 20. 2 times 10, not 3, and 4 times 5. Okay. And so I'm thinking about those three possibilities for how to make 20 and asking which ones of those, if I put them in, will the outside plus the inside give me 9? Well, this one right here, 4 plus 5 equals 9. So that means that should work. All right. This business of me doing this is just me kind of checking my work. 4x plus 5x is 9x. You don't necessarily have to write that down or anything, but that's what confirms that that is the correct factorization. So there's our answer. Right. All right, now let's think about this one here, x squared minus 13x plus 22. So if it's going to factor, it'll have to look like this. And the last times the last will have to equal 22. And my options here are pretty limited. 1 times 22 is a possibility, and 2 times 11 is a possibility. And that's it. Now, here's what we have to think about. I need the outside plus the inside to equal negative 13. Okay? I need it to equal negative 13. Let's understand that when I made my list of possibilities in this last problem, I actually didn't give a complete list, and here's why. I could have also added the following: -1 and -20. That would have created 20. -2 and -10 would have worked. -4 and -5 would have worked. But of course, the reason I didn't even bother to write those down is because I understood that I was trying to add these numbers together to make +9. So, of course, adding two negatives wouldn't work. But now that I do, in fact, want to make a negative in the middle term, it's absolutely appropriate to be thinking about the fact that, well, -1 times -22 would also do the trick, and -2 times -11 would do the trick. And so since we're trying to create a negative middle term, then the -2 and -11 are definitely the right choice because the outside plus the inside definitely equals -13x. So here's what you know. In problems where you have a positive constant term, right? Like these last couple, either both factors that you're trying to break that number into could be positive or both could be negative, and you make your choice based upon the sign of that middle term. Okay? But what if the constant itself is negative? What do we do then? So we're still breaking that down as x times x. So here I'm making -36. So in this case, what I would suggest is that you go ahead and list out all the possibilities, but this gets a little tricky because here's the thing. If you're going to make a -36, one of the numbers has to be negative and one of the numbers has to be positive. So -1 times 36. But it also could be like that, right? You could have the negative on the 1 or the negative on the 36. Same thing with -2 times 18. Well, the negative could be with the 2 or the negative could be with the 18. 3 times 12 is also a way to make 36. And please understand what I'm doing here. Negative 36 is going to be kind of a long list, actually. And what I'm doing as I make this list is I'm starting with 1 and then going to 2, then going to 3. Next, I'm going to go to 4. Then I'm going to go to 5. I'm going to say, can I divide 36 by 1, by 2, by 3, by 4, by 5? I'm just working my way up until the numbers that the pairs that I get closer and closer together. All right, so negative 4 times 9 and 4 times negative 9 are possibilities. And then finally, um, looks like negative 6 times 6 because 5 doesn't divide into 36 evenly. And then once these two factors, the two numbers in your pair kind of have collapsed down close to each other, that's when you know that your list is over. Now, after all that, remember what we're looking for. We need the outside plus the inside to equal positive 5. So this time we're looking to add the numbers that I've listed here, but one's positive and one's negative, right? So if I zero in on this one here, right? That pair, negative 4 plus 9, that does give me a plus 5. So I'm able to put those in and then verify that I do, in fact, get the correct middle term. Now, one thing I want to emphasize here is that I'm okay if you don't make this full list. So think about it from the standpoint of if you notice that 1 and 36 couldn't possibly be the right answer because how are you going to add negative 1 and 36 together to make 5? If you know that numbers that are that far apart couldn't possibly work, then don't bother to write them down. Okay? As I'm doing these examples, I'm going to try to, for the most part, stick to complete lists, um, just so that it's abundantly clear where I'm getting everything. But you can take some liberties there. And, if you look at negative 36 and realize just immediately, oh, negative 4 and positive 9, add to make 5 and multiply to make negative 36, good for you. And just write it down immediately. I'm totally fine with that. Just understand that these lists that I'm making over here on the sides, I'm just trying to be real clear about where everything comes from, um, for everybody that's watching. Okay, here's another where we have a negative 40, it looks like. So if it factors like that, negative 40. So again, some of these first ones, negative 1 times 40 and 1 times negative 40 might be incredibly obvious that they're not going to work, right? Because the numbers are just so darn far apart, you're never going to make negative 3q with your outside plus inside, right? So let's see, negative 4 times 10, 4 times negative 10. Those numbers are getting closer together, but they're not quite there. But negative 5 times 8 and 5 times negative 8. All right. Now, what I'm going to do is I'm going to make the wrong choice on purpose here momentarily. So let's say I wrote down the negative 5 times 8 and I got excited because I realized, oh, negative 5 and 8, that gives me a 3. And immediately I wrote down minus 5 plus 8. This is going to be wrong, by the way. So don't maybe write this part down yet. When you go to check, the reason we know we've done it wrong is because when we add those, negative 5 plus 8 is positive 3q. Well, if I get positive 3q and the answer is negative 3q, then I know what I've done is I have just swapped the signs. The signs are in the wrong place. Okay. So I realize, uh-oh, I made a mistake. This is why you check. And so say, all right, it's not going to be minus 5 and plus 8. If you get the correct value, like we got a 3, if you get the correct value, oops, but the wrong sign, then all you have to do is flip-flop which which number the negative goes with. So that's the one we want because 5 plus -8 is -3. So plus 5 minus 8 is going to do the trick. All right. Here's one, -8. You got y squared plus 7y minus 8. So it would have to look like this if it factors. And by the way, I keep saying if it factors. So the idea here is if you check all the possible ways that -8 can break down, and none of them will allow the outside and inside to add together to make the middle term, then that just means you can't factor it. So that's why I keep saying if it factors. So if you exhaust all the possibilities and it doesn't work, then you just say can't be factored. In this one, I'm looking for two things that multiply to make -8, but add to make +7. And this one right here is going to do the trick, isn't it? So -1 plus 8 is 7. So y minus 1 times y plus 8 is our answer. All right. I'm going to come back, or excuse me, I'm going to allow you to do some practice in just a little bit where I want you to work through some, but there's a few more nuances I need to show you. One is don't be alarmed if there's multiple variables involved, right? I know this can be intimidating at first, but the approach to one like this is the same. You're going to say, if a squared is my first term here, then that has to be produced by a times a. Now, 30b squared. If it was just 30, then you would start listing possibilities like 1 times 30, 2 times 15, and so on, right? Those would be the what you'd list. But in this case, um, you have 30b squared. So that means when you list things, you're going to list things like b and 30b to make 30b squared. But let's be clear that because this term here is a negative, it would have to be -b and -30b, right? -2b and -15b, -3b, -10b. And I can already spot the correct answer, but I'm going to list them all out here. So clearly the -3b plus -10b equals -13b, right? That's uh, what I'm looking for. Now, that's not exactly what we want, right? We want -13ab, but here's what that comes from. That comes from us actually multiplying first, or excuse me, multiplying outside time plus and then doing plus inside. So here's what that looks like. -3b minus 10b. So -3ab when you multiply the inside. And then minus 10ab. When you multiply the outside, add those together, you get your negative 13ab. Okay. All right. One other thing that I just want to backtrack to this previous page on. To make your lists more efficient, I've been listing out all the possibilities here, but even if you're inclined to make a big list like me, you can still cut down on how many you actually list out here in the following way. If you have a negative 40, then you know that the signs of the numbers have to be different. At the same time, if you have a negative middle term, then you know that the negative is going to have to be attached to the larger value. Okay. So, in other words, I could really cut this list in half, right? Knowing that the middle term is negative means from for 1 and 40, you would definitely want the negative to go with the 40. For 2 and 20, you would definitely want the negative to go with the 20. 4 and 10, definitely with the 10. And then 5 and negative 8, you definitely want it to go with the 8. So even when you're being really careful about listing all the possibilities, if you're doing that, you can still look ahead and say, well, because the middle term's negative, the negative better be with the larger value. Same thing down here in this example. I really knew before I even thought about it that hard that, right, that one's a possibility and that one's a possibility. Why is that? Because the middle term was positive. Okay. So just trying to save you a little bit of time on these. All right. In this next example, I just wanted to show this to you because we talked a little bit about descending order in some past videos. Here's an example where the polynomial is not written in descending order for us, at least at first. And so if that happens, that's all right. Feel free to just put it in that familiar descending order so that then you can say, all right, I know what I'm doing now. R and R, and then my 30 can break down in multiple ways. Here's another one where I have a plus 30, I have a minus 31 in the middle term. So it's got to be negative times a negative. And look at that. I think I found it on my first try, right? So I don't really have to keep going. Negative 1 times negative 30 would give me that middle term. So there's our factorization. All right. As you're working hard on this reverse foiling, and you do have to work hard on it, can be a tricky process. You also need to not forget about checking for factoring out a greatest common factor. The way I um, think of it is this: don't don't forget easy factoring. Don't forget easy factoring. So if there is a common factor that can come out of every single term, then you need to take that common factor out before doing anything else. So I have an x in common to each term. So factor that x out first. Then, if you end up with an expression that looks like you can maybe reverse FOIL it, then proceed to do that. So if it factors further, it would have to look like this, of course. An X there and an X there. And here, let me maybe make my more abbreviated list here. How do I make negative 4, understanding that because the middle term is positive, I actually would want to do the Um, Larger value is the positive number. So -1 times +4, right? -2 times +2. Well, clearly that first option's the right one because if we add together -1 plus 4, that gives us the 3, the +3 that we're looking for. So the factorization here is x minus 1, x plus 4 times x. All right. Maybe try this example. Press pause, try this yourself, and see if you can get to the right answer here. So we see that we can pull a 5 out of each term. We can pull an x cubed out of each term. And so 5x cubed times x squared gives me 5x to the fifth. 5x cubed times -5x gives me -25x to the fourth. And 5x cubed times -6 gives me -30x cubed. So if this does factor, it'll look like that. And we got to think about how do we break down -6? 1 times -6 or 2 times -3. Negatives with the bigger value because there's a negative here. X plus 1 times x minus 6 is the right choice there. All right, to wrap up this video, I have 6 different examples of ones where I'm asking you to factor, and notice it does say if possible. So maybe I'll just be upfront about the fact that out of the next 6, so you have one here, here, and here. So A, B, C, D, E, F. One of them doesn't factor. I'll just warn you about that. Go ahead and try all 6 that are on this page of your notes. Press pause, and then you can press play and come back and see how I factored those. All right, so part A is a nice one because there is only one way to break down a number like 17. It's a prime number, so it's got to be 1 times 17, right? And thankfully, if you do +1 and +17, when you check the outside plus the inside, you do get the middle term. And so there's your answer. And this one over here, -32. Lots of ways to break that down. I'm going to put the negative on the larger values here. 3 doesn't work, so I'll go up to 4. That does work. All right, 5 doesn't work, 6 doesn't work, so I think we're in good shape now. And clearly this is the choice because 4 plus -8 gives me the -4 that's in the middle term. So x plus 4 times x minus 8. Part C is one that is really important for you to not forget about easy factoring, right? So before you're trying to reverse FOIL anything, notice that a 2 factors out of every term. And so now we can think about the ways of breaking down 35. Notice that it's positive 35, but the middle term is negative. So that must mean that positive 35 is produced by multiplying 2 negatives together. That clearly is not going to add to make -12, but the other possibility of -5 times -7, that will work. And then part D is another one of those where we've got multiple variables involved, which is intimidating at first. But once again, just think about it like this. You're going to have to put an x here and an x here. And then you got to think about the ways of making negative 6y squared. So that could be, this is a middle term, right? Of that's negative. So it could be y and negative 6y, but it could also be 2y and negative 3y. Well, adding 2 and negative 3 gives me negative 1. So I think that's the trick. That's the correct answer there. So let's check 2xy, negative 3xy. Those add to make negative xy. So there's our factorization. All right, part E might throw you a little bit at first. Is there easy factoring that can be done here? Well, sure there is, right? We saw this in our greatest common factor video where if you have the same denominator throughout every term, go ahead and pull that denominator out. And that leaves you with something that looks a lot like the things we've been able to factor through this reverse foiling process. So let's think about negative 14. This is a negative number here, so we're thinking about putting the negative on the larger value. So looks like 2 and negative 7 will do the trick. Negative 7y plus 2y does give me negative 5y, so there's my answer. And then part F, last one, got negative 18, right? So we're trying to make a positive 4, so I'm going to put the negative with the smaller number and the positive with the larger number. So let's list out the possibilities. So it'll be negative 1 times 18, or negative 2 times 9, or negative 3 times 6. Those are my possibilities for making negative 18. But what you'll notice is that none of them work, right? For this one, negative 1 plus 18 is 17, right? That doesn't match my middle term. Negative 2 plus 9 equals 7. And negative 3 plus 6 is close, but not the same. So since none of those add up to give me that middle coefficient, we can simply say this does not factor.